Hi there students, this is Dr. John, your physics and math professor. Today we have another force and friction problem. This one is where a 1.1 kilogram textbook is held against a vertical wall with a hand that applies a force of 45 newtons. What is the coefficient of friction between the wall and the book? So here I've sketched it out for you a little bit. Here's your typical biology textbook, and this hand, which I didn't want to draw because it would look terrible, is holding with this pressure of this purple arrow here on this book, holding it against the wall. Now, what are the different forces involved in this? Well, this is a very similar question to that of a box that's sitting on the ground. In the case of a box sitting on the ground, this would be mg of gravity, and then this would be the normal force, which would be equal to mg of gravity. Because it's a straight up surface, normal force acts perpendicular to the surface. So in that case, this is sort of analogous to this, where the hand holding this book on the wall is similar to gravity holding this box down, and this purple one here, this other purple, pushing this way is the normal force pushing out from the wall. So this here is going to be the normal force. I'm going to draw this, write this in here. So this is going to be the normal, and this is going to be the applied force. And from here we know that the applied force is 45 newtons. So I'm going to write that in there. And since this surface is flat, like this, it's completely flat, just like this box here on the ground, then the normal force is going to be equal to the applied force. So I'm going to write that in there as well. That's also going to be equal to 45 because of this, because there's going to have to be equal and opposite forces. Let's just review Newton's laws here really quickly. The first law is this. It's a law of inertia. If something's moving, it's going to keep on moving, or if it's standing still, sitting still, it's going to stay sitting still unless there's unbalanced forces acting against it. So that's sort of the law of inertia, which is sort of common sense to us. Something that's in motion will continue to move. But if there are unbalanced forces, the acceleration caused by those unbalanced forces is going to be equated like this. The forces, the unbalanced forces, or the net forces is equal to the mass times the acceleration. And this last one here is for every force, there's an equal and opposite force. And that we see here in the box. The box is pushing down on the ground, hence the ground pushes up in the box with the equal force that the ground does. Same over here. The applied force here is 45 newtons that you're pushing this way, so hence the wall is pushing back at the book with the same force. That's why I wrote that in there. Now, what other forces do we have here? Well, obviously we have the force of gravity here. This one over here is mg, so this is mg, the force of gravity, which we happen to know that it's 1.1 kilograms. So 1.1 times 9.8, 10.78 newtons. That's the force that's acting downward here on gravity. Now, if this book is not slipping, it's not falling anywhere, so the force of friction over here, force of friction, is equal to, the way we normally do it, is the normal force times mu. We have the normal force right here, and mu is what we want to find. What would this force of friction need to be? It would need to be equal to this force that is applied by gravity, because this upward force of friction here has to be the same as this. So this over here, I'm going to write this over here, this is the force of friction, is going to be equal to the normal force times mu. We want to solve for mu, so let's do that, is equal to the force of friction divided by the normal force. What are those things here again? Let's just write those in. The force of friction has to be equal to this, 10.78, and the normal force, we already did here, is 45. 0.237. And remember, this is in newtons, so the coefficient of friction has no units. The units all cancel out. We have this in two significant figures, so let's do the final answer in two significant figures as well, and that would be 0.24. So mu is equal to 0.24. That's the answer we were looking for. That's the coefficient of friction between the biology book and the wall that keeps it from slipping down. And I hope this helped you with this simple problem. If it did, like and subscribe, and I'll see you in the next video. Bye-bye.